Hi, my name is Tim Adams. I'm with the Fraunhofer Institute of Scientific Computing and Intelligent Algorithms, SCAI, in Germany. I've been working in the lab of Professor Holger Fröhlich as a PhD student.
Hi, I'm Yasamin Salimi. I'm a postdoc at Fraunhofer SCAI as well, a colleague of Tim. I also work under Professor Holger Fröhlich, and mainly focusing on data harmonization.
Yeah, as we all know, researchers are investing a lot of time manually harmonizing data on a daily basis, and this takes, of course, a lot of time and resources. So in recent years, we've been researching how new technology like embedding models or large language models in general could help researchers ease this time burden. And we wanted to look into state-of-the-art text embedding models and see how they could actually support data harmonization in a semi-automated fashion, and see which models will actually perform well in this specific domain of Alzheimer's disease.
So semantic harmonization generally means when we are harmonizing variable from different cohort studies against one another. What it means is that the variables doesn't necessarily represent the same measurement or the same units. However, with minimal pre-processing steps, one can make them equivalent. For example, for the variable gender in different cohort studies, it could be recorded as 0 and 1, or it could be recorded as female and male, where both variables are semantically equal, but still further pre-processing step is required to make them, compatible with one another. Over the last decades, a lot of studies have been focusing on doing research using single cohort studies. This does not necessarily represent the general population, meaning the results are not basically applied for all the general population. What we wanted to do is through semantic harmonization or through data harmonization, basically, we wanted to accelerate using multiple cohort studies for research. So to do cross-cohort analysis, basically, it's a very time-consuming task, given that the cohort studies use their own naming convention. And here we try to harmonize cohorts against one another, hoping that more research will be done using multiple cohort studies and potentially resulting in more robust results.
Yeah, not exactly hurdles, but what we were doing is we were comparing our results for our specific, so domain-specific benchmark for Alzheimer's disease with big established general purpose benchmarks. And what we found, what we did not expect, is that different models, especially big models or very recent models from big companies, did not perform as well in these specific benchmarks as they would do in general purpose benchmarks. And we actually found that for some small models, even older models, they may even perform better than those big models in those specific use case of Alzheimer's disease. Yeah, first of all, we found that models that perform well in these general benchmarks, as I said previously, do not really perform well in these, or not necessarily perform well in this real-world clinical harmonization use cases, especially Alzheimer's. So this really highlights the need for such domain-specific benchmarks. The second thing that we are happy that we can provide to the research community based on the paper is that we have a benchmark that is now public, that can be used using Python. So this can be used going on to the futures to benchmark even newer models that come out and see whether or not they would be suited for this use case.
We additionally highlighted how important it is for these data dictionaries that are provided from the cohort studies to be more descriptive, and how much their description impacts the data harmonization through semi-automatic or automatic data harmonization. So through this paper, we highlighted how important is the quality of the metadata that is provided to us in order to be able to do automatic data harmonization. And also, even through manual harmonization, it is very important to know what exactly those measurements contain to make sure that the cohorts are being utilized in the correct way for cross-cohort analysis and basically to generate more robust results.
Yeah, generally for researchers and data stewards that are handling data and data harmonization on a daily basis, we are generally hoping that at some point such automated harmonization workflows may be mature enough to actually assist in these tasks, so that a lot of workload will be taken from these researchers, and we are hoping that our benchmark can contribute to this.